Let's create a new schematic and save it first on our folder. PAF. And then we're going to place now the components. So let's start first with an op amp. And so we're going to use op amp resistor on the negative, feedback resistor. Sorry, op amp. We're going to use op amp. Then we'll remove it here. A voltage source and a ground. And for this, the RC circuit, the wine bridge oscillator, we're going to place it here and then capacitor here. Capacitor in series and a resistor. And another voltage source like this. So let's connect the components. R1 would be connected to the negative supply, and then the other end would be connected to the ground. Then for the positive or the non-inverting input, we're going to connect these two. Then both of these are going to ground. The feedback resistor will be connected to the output, and this will be connected to the inverting side. And let's assign output as modulating signal. And let's try to run 10 micro, 10 milli I'm getting, 10 micro. And then let's start at 0 volts. And let's check the modulating signal. And let's check. Oh, this, they're not connected. Let's connect it first and then rerun the simulation. So as you can see, we have a sine wave here. But the amplitude I think is around 24 millivolts. So we need to amplify this in order to produce a good pulse amplitude modulation signal. Let's insert another op amp. Copy this one. So this one's to the ground. We have a feedback resistor. We're going to feed the signal to the non-inverting amplifier. So let's copy this. And the input would be coming from the modulation signal. This is 1K, so maybe we can do a gain of 100. Oops, this one is not connected. Now, because of the gain, we have now a steady 2.4 volts sine wave. Let's edit the transient simulation command, and maybe we can put 50 milliseconds and 1 millisecond. So now we have a clean sine wave. Now we can produce the square wave generator. Let's put the text. This one is in the wave generator. Our modulator circuit consists of a transistor, NPN type, and we need to put a low pass filter on our wine bridge oscillator before we fed it to the collector terminal. So let's move the modulating signal from here to here, and maybe we can duplicate the terminal and put a resistor here. The value of resistor is 15K, and our capacitor is 0.75 nano. 0.75 nano. The output taken across the capacitor will be fed into the collector circuit. And we're going to need a resistor. And the output will be fed into the base. And the emitter is connected to the ground. Let's write a terminal name on the collector and name it pump. And let's check the simulation. So this is our modulating signal. And we're going to check the output across. We're going to check the output across the modulating signal. Oh, I forgot to assign a value for our transistor, we're going to use 2N222. Let's edit the simulation command.
Ha? Nakita mo na guys ako ba? Lalo na nabago ba?
The value of our capacitor will be 0.00095 farad.
Baka mo na magaling mag-egg, ano, tiyak mo pa eh. Kapatagal na ako, ay, mag-release ko naman.
Let's check the output of our pulse amplitude modulator circuit. With this one as our modulating signal, the appropriate pulse amplitude. With this one as our modulating signal, the appropriate pulse amplitude modulator output is produced through LTCs.
Meron na.
So we can observe by varying the capacitance, the square wave frequency changes, and it depends on our preference whether we like our approximation to the original sine wave frequency to match our output. And that's all for our pulse amplitude modulator circuit.